Human beings have always used drugs of all kinds, for medicinal purposes or for pleasure. Alcohol, cocaine, morphine, the place where all drugs act is in the brain. Biology is now able to explain how they work inside of our heads, while research on drugs has enabled science to better understand how the brain itself functions. Tobacco and alcohol, sold freely, are the most widely consumed substances in the world. However, scientists have long considered them as full-fledged narcotics. Tobacco was originally consumed in the Caribbean and Central America as a medicinal and ritual plant. In the 15th and 16th centuries, it was discovered by the great explorers. The Frenchman, Jean Nicot, started tobacco growing in Europe, and his name is immortalized in the plant's scientific name. Smoked, sniffed, or chewed, tobacco soon became very fashionable and spread throughout the world. Today, more than 1 billion people in the world smoke. There are 7 times more smokers than illegal drug users. Heightened concentration, alertness, and memory are all cigarettes have to offer to one's mind. Jean-Paul Tassin, a neuropharmacologist, is studying this paradox at the Collège de France.
The exhilarating effect triggered by tobacco is much subtler than the effect of morphine, which is much more powerful, or of psychostimulants. But this is precisely the point. Because it is subtle, we can repeat the experience and use it in everyday life. We can spend an enjoyable day smoking all along and continue to pursue a normal social life. For a long time we thought that the addictive properties of tobacco depended on one of the active ingredients, nicotine. And we have a paradox, in fact. All the substances that are habit-forming in man, like amphetamine, heroin, cocaine, animals consume them quickly and in large quantities, and they become addicted to these substances. When you give them nicotine, they're not very attracted to it.
Animals smoke only for the good cause, but public health campaigns can do almost nothing against cigarette addiction. And for scientists, nicotine, the main ingredient of tobacco, has long been the ideal guilty party.
If you think this looks ridiculous, remember, smoking is just as unnatural for you as it is for them.
Studying how drugs work would not have been possible without rats or mice. They share many of the same genes as human beings, and drugs stir up the same kinds of tempests in their brains. In fact, all of humanity is morally indebted to these little creatures. We can drug rats, engineer their genes, and even slice them up. It's their unfortunate but necessary daily destiny in the laboratories where the state of these rats is compared with normal or control rats. In her laboratory in Bordeaux, a very active center for drug studies, Martine Cador is studying the behavior of rats under the influence of nicotine.
It's true that nicotine is a paradoxical abuse substance because it is a very powerful addictive, and yet it is not a very powerful psychotropic drug, which means, in fact, that nicotine doesn't give you the altered state of consciousness that you get with alcohol, cocaine, or heroin. Smoking, consuming tobacco, increases one's powers of concentration, one's capacity to reason, and the level of alertness. These are the stimulating characteristics of tobacco. But along with that, there are also the sedative properties, meaning that smoking, and this is a subjective sensation the smoker experiences, reduces stress. A lot of people smoke in stressful situations. So this is where we see the two facets of the effects of nicotine, and the two are not at all contradictory. We see the same thing with a number of substances that people consume. Alcohol, for example, can act both as a stimulant and a sedative. Here, the rat is placed in a self-administration cage with 2 holes. One hole is reinforced, meaning that each time the rat pokes his nose into the hole, the computer activates a pump that pushes the syringe and gives the rat an intravenous dose of nicotine. With the non-reinforced hole, nothing happens. So in the course of the self-injection sessions, which take place once a day over several weeks, we observe that the number of visits to the reinforced hole increases over the period. This is what we call acquisition of self-administration behavior.
In a few days, the rat learns how to give itself an injection of nicotine.
Under a certain minimum dose, the animal doesn't detect the nicotine, so he doesn't self-dose the substance, and above a certain threshold, the dose becomes repellent. So we have to work within a very narrow margin. And unlike cocaine, the animal consumes very little. When you smoke and you inhale, the smoke penetrates the lungs. And there you have the pulmonary alveoli, which are highly irrigated. And nicotine transits very quickly across these alveoli and is carried very quickly to the brain. Just to give you an idea, it takes about 10 seconds or a little less for the nicotine to reach the brain, which just about corresponds to an intravenous injection in the animal. Then, as far as the dose goes, it's about the same thing. For example, someone who smokes a pack a day. Well, it depends, of course, on how they smoke. Between a person who inhales the smoke deeply and another who just puffs a little bit, there'll be a big difference in the level of nicotine absorption. But overall, we get the same concentration of nicotine, relative to the weight, naturally, the weight of the individual. So for someone who smokes, say, a pack of cigarettes a day, if we figure 1 cigarette equals 20 inhalations, we get 400 inhalations. And that's equivalent to 400 intravenous injections of nicotine, which is quite a lot.
Here we see nicotine in its crystallized form. Like all drugs, in order to act, it takes over the brain's communication system. For our brain spends most of its time talking with itself. For it to function smoothly, there has to be an ongoing dialogue between our 100 billion nerve cells, the neurons. To circulate the information, the neurons send each other chemical messengers called neurotransmitters. Whether it be pleasure or pain, or the rate of information exchange, the neurotransmitters control a subtle and complex equilibrium that regulates all the functions of our organism. Between each neuron, there is a tiny space bustling with activity. It is here in the synapse that the neurotransmitters do their job. To transmit information from one neuron to another, they fit into their corresponding receptors. If nicotine improves one's powers of concentration and memory, it is because it takes over the network in charge of these very functions in the brain. It's the acetylcholine, or ACH network, and its receptors are even called the nicotinic receptors. But nicotine is much stronger than acetylcholine. It triggers the release of another neurotransmitter, dopamine, a molecule at the origin of the sensation of pleasure obtained by all drugs. And yet we've known for a few years now that nicotine is not the only guilty party. We suspect it has accomplices.
One of the hypotheses we're testing in the laboratory is precisely to see if in tobacco there might not, in fact, be other substances that facilitate the addictive properties of nicotine.
These substances are thought to act directly on the dopamine, the pleasure molecule. When it has accomplished its mission, dopamine is recaptured into its original neuron. At this point, an enzyme, monoamine oxidase, or MAO, is supposed to destroy it. When you smoke a cigarette, a chemical prevents the MAO from destroying the dopamine. We say that it is inhibiting the monoamine oxidase. As a result, the dopamine continues to stimulate the receptors longer than normal and produces more pleasure. The mechanism even has an antidepressant effect.
What we're studying here in the laboratory is just how these monoamine oxidase inhibitors increase the addictive power of nicotine. We're working on animals, rats in a situation where they can give themselves intravenous doses of nicotine. And we have two groups of rats. One group that can give themselves doses of nicotine alone, and a second group that has access to nicotine plus the monoamine oxidase inhibitors. And what we're seeing from the first set of results that we got from the lab is that the animals that have access to nicotine plus the monoamine oxidase inhibitors self-inject more nicotine and will do a lot more work to obtain a dose of nicotine. That's to say, they demonstrate a much higher level of motivation to self-inject the drug.
The conclusion of the experiment is that nicotine is probably not the only substance responsible for cigarette addiction. But what other substances are involved? Scientists are still trying to identify them. And they have a wide range of possible suspects. We know that there are as many as 4,000 chemical substances in tobacco smoke. Some are involved in addiction. About 60 of them are toxic and carcinogenic. It's easy to understand why smoking kills. From cancer to cardiovascular diseases, today close to 5 million people die from cigarettes every year.
We're going to leave this here for you so you can see what 1,200 people actually look like.
Et je danse de tout mon cœur, car je vais grandir. Et quand je serai moins petite, je fumerai comme un sapeur.
Et elle fumait, comme des sapeurs, comme si déjà elle voulait battre l'homme sur son propre terrain. Concours de la plus jolie fumeuse en 1927. Pour ces dames, l'herbe à Nico remplace soudain le thé de 5 heures, la garçonne s'efface dans des volutes de paradis artificiels et Marilyn Monroe perce déjà sous la femme sapeur.
Mademoiselle Maud Lottie est proclamée la plus gracieuse fumeuse de France du concours organisé par le fumeur et par Paris qui chante. Concours de cigare vitesse. Messieurs, préparez-vous. Vous êtes prêts?
1930. Aux hommes, comme d'habitude, il reste l'effort athlétique, la rage de vaincre les femmes à la pointe du mégot, même si certains retrouvent au Monsieur Freud des gestes d'enfants pour suçoter leurs cigarettes, comme la tétine d'un biberon.
It was not until the first half of the 19th century that cigarettes came onto the scene. They were soon being produced on an industrial scale, but it was in the 20th century that their consumption skyrocketed, boosted by the free distribution to soldiers in particular. Today, the tobacco industry produces 5.5 trillion cigarettes a year.
Let me take your hand, try to understand. I will always care.
Hard-hitting prevention campaigns, price increases, bans on smoking in public places. The consumption of tobacco is decreasing in the developed countries. But the tobacco industrialists are not about to go bankrupt. In the poorer countries, 1 man out of 2 is a smoker. Scientists used to think they knew everything there was to know about nicotine, but it still has some unpleasant surprises in store. Pier Vincenzo Piazza suspects that it even damages the neurons.
When a person stops smoking, one of the fundamental effects of withdrawal is the perturbation of the memory and significant cognitive disorders. The question is, how can this come about? We've discovered that there are, in fact, 2 specific zones of the brain where there is a very active regeneration of the neurons, where there's continuous regeneration of the neurons. And in a region of the brain called the hippocampus, these new neurons seem to be very important for the memory. So we try to observe the effects of nicotine on these immature neurons, these baby neurons, but in an adult brain, and that play a role in certain cognitive processes. And we observed that nicotine has very significant negative effects on these neurons. In fact, it reduces the production to about 50%. So it kills or blocks the production of new neurons in this part of the brain by about 50%.
No one yet knows if this damage is reversible. There's an even stronger link between nicotine and memory. Hervé Alain knows a great deal about the effects of nicotine. However, he's not an expert in cigarettes, but a specialist in Alzheimer's disease.
Alzheimer's disease is what we used to call a degeneration of the neurons. That means our neurons, which are the noble cells of the brain, the cells that, among other tasks, are responsible for synthesizing the neurotransmitters, those substances that serve as connections between the different zones of the brain, these neurons degenerate and die.
Alzheimer's disease begins with the death of these neurons. It's a disease that leads to serious judgment and memory disorders, and that affects 15 million people in the world.
It was an important discovery when we found that it was the neurons in the hippocampus that suffered the first. For the hippocampus is a little bit like our brain's hard drive. That's where information and memories are first stored. And once the hippocampus has done its job, then the long-term memory, like in a library, will be filed away in different zones of the cortex.
In Alzheimer's disease, the neurons that die are precisely the ones that produce the librarian of our memories, acetylcholine, the neurotransmitter that uses the nicotinic receptors.
These nicotinic receptors come into play in the memorization process. in our capacity to focus our attention. When you watch TV or talk with someone, you have to listen. You have to listen to each other to follow. Well, this capacity to listen to what the other person is saying or doing, this is called attention. And it is greatly dependent on the smooth functioning of the nicotinic receptors. We figure that by stimulating the nicotinic receptors, we'll not only be improving the functioning of our memory, of our attention, like I said, but at the same time, and this remains to be proven in humans, we'll maybe be reducing or even stopping the harmful effects of one of man's worst enemies, Alzheimer's. So you see how we go from tobacco, from nicotine. Nicotine and the nicotinic receptors were discovered quite a while ago, how we make our way to state-of-the-art neurobiology. All the world's foremost research teams are working on what I was just talking about. How is it that by stimulating a receptor we can act on the life and death of the cells or the toxicity of certain substances?
Since nicotine acts upon the very same receptors, scientists used the effects of tobacco on the brain as a model to create the first medications against Alzheimer's. Medicine that slows the evolution of the disease by targeting the nicotinic receptors.
So the pharmacology of the nicotinic receptors responds to the same strategy, or the same hypotheses, of the deficit in functioning of acetylcholine in the brain. But instead of acting on the neurotransmitter itself, we act on the receptors. Now, you could very well say, might as well just give tobacco to Alzheimer's patients. And for a long time, we did think that tobacco was a factor of protection.
Était un facteur de protection.
We no longer agree with this theory that tobacco can protect, simply because tobacco can lead to intellectual degeneration, not on account of its effect on the nicotinic receptors, which seems to be positive, but here's the bad news. At the same time, tobacco is harmful to vascularization. And Alzheimer's makes the blood vessels more fragile. So that's why, I'll just resume what I said, the first studies that led us to believe that tobacco could protect against Alzheimer's, well, they're all thrown into question because of this adverse and destructive effect of tobacco on the brain's blood vessels. So today, the tendency, the message we're trying to get across is that, on the contrary, tobacco has now been recognized as a risk factor in Alzheimer's disease.
Weakening of the brain's blood vessels, addiction, toxic components, deterioration of the neurons, there's no doubt about it. Tobacco is not the brain's best friend. But there's something even more harmful. More than 1 billion smokers in the world is already quite a lot, but it's nothing compared to the 2 billion occasional drinkers on Earth. Alcohol, sold freely in most countries, is produced by the fermentation of sugar-rich fruits and grains or by distillation. In our society, the consumption of alcohol is a common everyday fact, from the aperitif to a hearty meal there's always a good reason to have a drink. The words alcohol and drugs are rarely associated, especially in France, where 20% of the population drinks to excess. At the addictology service of Philippe Battel, 80% of the consultations are alcohol-related.
If you say alcohol is a drug, people hit the ceiling, and not only winemakers and alcohol manufacturers. Even the Minister of Health gets indignant. Monsieur Mattei said in a widely followed TV show that alcohol is not a drug, and that there are even scientists who say the same thing. So I think that we have to talk Turkey. If a drug is a substance that has the potential to create an addiction in a subject who uses it, then there's no two ways about it. Alcohol is a drug.
Excusez-moi, est-ce que vous buvez plus de 3 verres d'alcool par jour?
Moi, non.
Non?
T'es sûr? 3 par jour.
Et vous, mesdames, plus de 3 verres par jour?
Non, certainement pas.
3 verres par jour? Pas 3, hein.
Dites-moi, est-ce que vous buvez plus de 3 verres d'alcool par jour?
3 verres d'alcool? Non,
c'est rien. Moi, je ne bois jamais.
Oh, ben, moi, j'en ai bu un verre. Hein.
Non. Pas 3 verres, non.
Aujourd'hui, dans notre pays, personne ne semble boire plus de 3 verres par jour. Heureusement, car les études montrent qu'au-delà, les risques d'avoir un cancer augmentent considérablement.
If we were to take the number of deaths as a benchmark, then alcohol takes the prize. 45,000 a year in France. 3 times the number in the recent heat wave. What are we doing in this country to help patients who have a problem with alcohol? Are the measures we're taking in proportion with the number of deaths, in proportion with the horrible suffering that we find in all those families? You can't put a figure on that.
And so this is Christmas. Another year, a new one just begun. And so this is Christmas.
Alcohol abuse prevention campaigns invariably focus on the dangers of driving under the influence of alcohol. They don't touch on the domestic violence and the depression that often go hand in hand with alcohol. As for alcoholism, it comes across more as a footnote in the public health messages. Yet this scourge afflicts 76 million people in the world, and like all drugs, alcohol seriously modifies the brain.
Let's hope it's a good one.
Its impact on the brain is even so complex that researchers like Philip Gorwood call it the dirty drug.
Alcohol also has a particularity that makes it even more difficult to analyze. It has an incredible rate of diffusion. It's a very small molecule. It's capable of passing through the cell membrane and thus diffusing very easily through the brain, through the placenta, through the neuron itself. But alcohol acts on many different receptors and even in the interior of the cell. This makes it very complicated because we can't study one receptor that is the focal point of neurological effects and psychological centers following the consumption of alcohol.
Most drugs focus their effects on a certain type of receptor. But ethanol, the active ingredient in alcohol, has an impact on just about the entire system. It affects the acetylcholine, the dopamine, and the glutamate systems, but above all, the GABA system. In an alcohol-free brain, the GABA acts as the great brake on neuronal activity. By targeting the GABA receptors, ethanol accentuates the slowing down of the brain. And that explains the relaxing effects of alcohol, but also the sleepiness and dulling of the reflexes that cause 1/3 of all mortal traffic accidents.
The repetition of the alcohol's activity leads to a phenomenon of adaptation. The living organism has one overriding philosophy in life: homeostasis. The term is a mouthful, but the concept is simple. It's the tendency to return to a state of equilibrium. There's nothing more conservative than the brain and all the other human organs. When something comes and modifies its dynamics, it systematically tries to bring it back to a level that's more adapted to its usual mode of functioning. As alcohol really stimulates GABA, GABA is a brake, a neuromodulator, how is the organism going to combat this inhibition? Because the brain needs to function for our everyday life. Get up in the morning, get something to eat, work. So the organism desensitizes the GABA receptors. What does that mean? In short, it means that there'll be fewer GABA receptors so as to have less of the braking effect.
It's this type of adaptation that eventually fixes alcoholism in the neurons. The brain is forced to create a new state of equilibrium. When an alcoholic stops drinking, the delicate balance of the brain collapses, and this causes withdrawal symptoms.
The symptoms are nervousness in the morning, tremors in the extremities, confusion, anxiety, sometimes obsession, sweating and tachycardia. The heart beats faster, and there's high blood pressure. If these symptoms are not treated, usually the alcoholic treats himself by taking a drink to calm the symptoms. As the day goes on, in the morning, the full-blown withdrawal symptoms come on, sometimes quite violently, with the shakes throughout the body. Psychologically, obsession will give way to real confusion, with delirium associated with perception disorders, meaning the subject will fabricate images from objects he has in his field of vision. For example, we often see it in the literature or in films. In delirium tremens, he'll see a sock and think it's a rat. And then he'll see thousands of little rats swarming into his field of vision. And this is terribly distressing. This cerebral flare-up can lead to generalized convulsions, and in rare cases, 6%, to the death of the subject due to a hyperactivity of the brain and a severe state of dehydration.
Through a mechanism that we don't yet fully understand, alcohol causes dopamine to be released in a small region of the brain that controls the sensations of pleasure, the nucleus accumbens. This is a process common to all drugs and plays a crucial role in addiction. In recent years, medical imaging techniques have enabled researchers like Jean-Luc Martineau to measure the damage caused by alcohol to the whole brain.
About 15 years ago, we started studying patients that were regular drinkers. We were attempting to measure the energy consumption of different parts of the brain in these patients, and if it were different from that in normal subjects. We observed that glucose was being metabolized at a much slower rate, and glucose is the brain's only source of energy in all the anterior regions of the brain. We also noticed that when we looked for a correlation between the energy consumption in the anterior regions of the brain, and a subject's performance on certain tests, that there was a relationship. That is, the lower the energetic activity, the lower the results on the information selection tests, tests of immediate memory, and behavioral supervision and execution tests.
Supervision d'exécution des comportements.
Over the following years, we tried to find out if, in addition to these functional modifications, there were any structural modifications in the brain itself. And for that, we used MRI, magnetic resonance imaging, which gives very good images of the shape of the brain, of its anatomy, of the gray matter and the white matter.
Gray matter is not just an expression. It designates the cell bodies of neurons, that is to say, their nuclei. As for white matter, it constitutes the wiring of these neurons, the network that transmits the information in the brain.
We studied the same type of patient, that is, patients hospitalized in Professor Reynaud's addictology service in Villejuif, and these patients were habitual drinkers who had asked to be cured of drinking, but weren't in a critical condition and had no particular physical distress. We did MRIs on these patients, and the results we obtained using a computer program designed to measure the gray matter and the white matter showed that there was a marked decrease in the gray matter in the anterior regions of the brain. That is to say, in the front and frontal medial parts, the regions between the two spheres. More recently, in the last few years, the techniques of image analysis have shown that even in the case of moderate alcohol consumption, we can detect changes not only in the functioning, but also in the structure and even in the ultrastructure of the brain.
These images show that high doses of alcohol atrophy the brain. In certain alcoholics, the extensive degradation that scientists have found can even be seen with the naked eye.
So that's the present state of our knowledge. We don't know if this damage is reversible. We think that it may be reversible if the alcohol consumption stops, but we don't know to what extent these elements may be reversible. Of course, we're continuing the research to come up with the answers. I'm somewhat horrified by the results. They indicate that alcohol is really an even more toxic substance than I had imagined.
For a long time now, specialists in alcohol have been seeking to identify the factors implicated in a propensity to alcoholism, and it's genetics that is beginning to provide solid answers.
The factors that could lead to alcohol dependence are very, very complex because there's a mixture of factors: culture, family, education, individual temperament, psychiatric pathology, as well as genetic factors. The whole makes a complex blend, difficult to sort out, and as a result, certain subjects are more vulnerable than others. If we just look at the genetic factor, we are not all equal. In France, a small portion, 2 to 5% of the population, is not very good at eliminating alcohol because they don't have the right genes, and maybe it's not such a bad thing, to eliminate ethanol. So the alcohol metabolite, the primary product of the breakdown of the alcohol molecule, very quickly accumulates in the blood. and it's a very disagreeable metabolite. The symptoms are reddening, paleness, nausea, vomiting, sometimes. So the slightest quantity of alcohol is disastrous. I was saying that 2 to 5% of the French have this intolerance. With Asians in Korea, in Japan, the figure is over 40%. This high frequency of alcohol intolerance quite naturally leads to a lower risk of alcohol dependence.
The gene at the origin of this intolerance forms a defense against alcoholism. On the contrary, those of us who resist alcohol can very well be headed for trouble. The global consumption of alcohol is on the decrease, but teenagers and young adults, young women in particular, are drinking more and more, and younger. This precocity makes them more prone to alcoholism.
When you drink 3, 4, 5 beers, and you manage not to pass out and even more, you keep your self-control, and you even have a certain control over your movements. Even if you don't seem as intoxicated as your friends who've had the same amount, that doesn't mean, hey, I'm a real man, I can hold my liquor. It means that you should be aware that you're at risk of becoming alcohol dependent.
To define the role played by the genetic background in the development of alcoholism, scientists have carried out wide-reaching studies on twins and adopted children. Studies that allow them to identify the respective roles of genetics and family history.
There's been a lot of progress in the past 20 to 30 years thanks to 2 somewhat odd techniques that allow us to pinpoint the factors that we had a hard time separating before. The factors of family and education. The fact of living in a family with an alcoholic father, for example, and the genetic factors. The fact of getting our genes from our father or from our mother. These are techniques called twin and adoption studies, so we can pick out what comes from the shared family environment and what comes from the genes inherited from one's parents. There are now about 20 of these twin studies going on in the world, with 10,000 twins recruited from different countries. So we have reached some solid conclusions, and contrary to long-held beliefs, the genetic factors are much more important than the shared family factors. Of course, living in a family where alcohol flows like water, or the daily consumption of alcohol is seen as normal, or even if you have a parent who's a problem drinker, cannot be discounted. But inheriting genes that give a propensity towards developing this kind of problem is even more important than the family factors, which do have their effect. So there are several sources, and now they estimate the genetic factors at about 55%. That is to say, a little more than half the parameters that figure into why you would be at risk to become alcohol dependent in your life are explained by genetic factors. So it's really a more significant proportion than we'd thought.
Geneticists have given up trying to find the alcoholism gene. On the other hand, they have identified several key genes. Among them is the one responsible for producing one of the dopamine receptors, the D2 receptor. Everyone has this gene in their chromosomes, but it can be found in different forms called alleles. In a majority of alcoholics, this allele is a little longer than normal, a characteristic that seems to disturb the production of D2 receptors.
One of the forms of the D2, the gene that codes the dopaminergic receptor D2, is a little bit longer in alcoholics than in the control subjects. It increases by 30% the risk of alcohol dependence. But it's ridiculous. That doesn't explain the disease. Increasing just a bit the risk of the disease is not a scientific explanation of the development of the dysfunction, but the fact that it's systematically present is significant.
This abnormal allele can also be found in cocaine and heroin users. Many scientists think that this gene could be one of the key factors in a propensity to substance addiction. But there are other factors, and genes alone are not the whole answer.
I've done quite a bit of genetic research, and every time that I discover a vulnerability factor, I have it myself. I have the S allele serotonin carrier gene indicating a propensity to suicide. I have the A1 allele indicating a predisposition to alcoholism. And I always tell this to my patients and to the people participating in the genetic research, because I don't think I'm any worse for it. I know that I may be a little bit more vulnerable than the next person, but like a lot of people that are aware of their vulnerability, I have to be just a little more careful. Well, averting the risk of suicide is not all that simple. If I'm depressed, I'll go consult a psychiatrist. It's tricky, given that I myself am a psychiatrist, but I can find one. And in any case, if you have a vulnerability gene, it will only develop if it happens to be in the right environment, and that is very important. It's also a line of research that's expanding in addiction genetics, trying to understand when there's a vulnerability gene, what sort of event, at what moment, in what circumstances will the pathology be triggered.
Certain people are afraid of systematic testing for these vulnerability genes that would encourage employers and insurance companies to implement abusive practices. An idea diametrically opposed to the line of thinking followed by scientists for whom a propensity is in no way predestination. Alcohol and tobacco are the most widely consumed drugs in the world. They're also the most dangerous to one's health. Scientists are now in a position to make an accurate evaluation of the extraordinary complexity of their action on the brain. Long glossed over by a collective denial, they are now considered full-fledged narcotic drugs.